Hello, I'm called Mr. Asnake from Ethiopia. I'm doing my work at Awasa University as a physics lecturer. Today, we'll see together about uncertainty in measurement and significant digits. ጤና ይስጥልኝ ውድ ተማሪዎቼ፣ እኔ መምህር አስናቀ ኃይሉ እባላለሁ። በአዋሳ ዩኒቨርሲቲ በፊዚክስ የትምህርት ክፍል መምህር ሲሆን በአሻሚነት አሊያ በአጠራጣሪነት በንጽጽር ወቅት እና በአስፈላጊ ዲጂቶች ዙሪያ እንማማራለን። ታዲያ ቻናሉን ለጓደኞቻችሁን ማጋራት ደግሞም ሀሳባችሁን መስጠት እንዳትዘነጉ በትህትና ለመጠየቅ እወዳለሁ። ጥሩ። That's good. As you know, my dears, before giving a narration about uncertainty in measurement and then significant digits, we have to know something. Was that in physics, there are two distinct and then independent aspects of measurement related to uncertainties. Those are known as precision and then accuracy. Great. በፊዚክስ ውስጥ በንጽጽር ወይም በመለኪያ ውስጥ የተያያዙ ሁለት የተለያዩ እና ገለልተኛ ገጽታዎች አሉ። እነሱም ፕሬሲሽን እና አኩሬሲ ይባላሉ። ጥሩ። ታዲያ ልጆች ስለ ፕሪሲሽን እና አኩሬሲን በቅድሚያ ከነተምሳሌዎቹ ወይም ምሳሌዎቹ በአግባቡ ለማየት ለመቃኘት እንሞክራለን። That's good. Look, my dears. Accuracy refers to the closeness of a measured value to the true, to the standard, to the known value. For instance, look, if you measure a table 1.4 meters long, when it is actually 1.42 meters long, you have high degree of accuracy. You are very close to the actual value. Why for 1.4 meters and then 1.42 meters, almost they are near each other. And then 1.4 is near to 1.42. That means there is closeness of a measured value to the true value. The true value in this case is 1.42, but the measured value is 1.4. Great. Another one is known as precision, which refers to the closeness of two or more measurements to each other without referring to the true value as what we have discussed in the case of accuracy. Example, if you measure the table multiple times and then get a reading of 1.48 meter and then 1.49 meter, you have high degree of precision, but you might not be very accurate if the true length is 1.52 meter. 2 meter. From this we understand something, what that precision and then accuracy are independent. That means A measurement can be precise but inaccurate, or accurate but imprecise. Great. So to understand what we said, so we have to use what we call it dartboard. Ideas. We are almost five measured values which are close each other, which found within the central circle. They all are close each other, okay, and hence they are precise. The same thing holds true. All the measured values are almost close to the true, the noun, to the standard value, and hence they are, or simply the measurement, are accurate. Look the second one. Our measured value could be precise and then inaccurate. Look, all the measured values are close each other. How many measured values do you see here? 1, 2, 3, 4, 5 measured values. Despite the fact that they are close each other, at the same time they are far from the central or the noun or the standard value, and hence, yes, there is precise or they are precise, but the values are inaccurate. Look the third one, imprecise, and then the value could be accurate. All the measured values, they are not close each other, and hence the measurements are imprecise, despite the fact that all the measured values are close to the accepted, to the standard, to the noun value, and hence they are accurate. Look, the last one, measurement can be imprecise and then inaccurate. Look, these are the values. They are not close each other, and hence the measurement is, or the measurements are imprecise, and then log, all the measurement values are far from the central, from the noun, from the accepted values, standard values, and hence inaccurate. That's good. If so, what the meaning of uncertainty in measurement? Great. In Amharic በንጽጽር ውስጥ ያለው አለመተማመን ማለት አንድ የንጽጽር ዋጋ እንደሚገኝበት በሚጠበቀው የእሴቶች ክልል ላይ ያለው ስፋት ወይም ስፋትን ያመለክታል። Uncertainty in measurement refers to the range of possible values within which a measurement is expected to lie. Okay. In short, this means a lack of confidence about something. Look the example. A weather forecast stating a 70% chance of rain. We know it might rain, but we are not certain. If this is so, errors fall into two categories, which leads to uncertainty. Those are known as systematic errors and then random errors. Systematic errors in Amharic known as ስርዓታዊ ስህተቶች. Random error or errors is known as አጋጣሚ ስህተቶች. Great. Systematic errors and then random errors are two types of errors that can occur in measurements. Systematic errors are consistent, repeatable errors that affect the measurements in the same direction. This means that they always introduce a bias in the same way, either overestimating or underestimating the true value. Okay, what consistent means in systematic error? The error always occur in the same direction. Look at the example. A miscalibrated scale might constantly weigh object this much grams or 3 grams heavier than the actual weight. It's repeatable. What the meaning of repeatable under a systematic error? The error is likely to occur again and again under the same condition. Affects measurements in the same direction. The systematic error always pushes the measurement in the same direction, either higher or lower than the true value, as what we have seen as example on our previous slide. Great. If so, what are the common causative agents? Great. The common causes of a systematic error include 1. Instrumental calibration issues. Miscalibrated instruments can constantly produce inaccurate readings. 2. Experimental design flaws. ይህ በቤተ ሙከራ ውስጥ የሚደረጉ የሚሰሩ የሚከናወኑ ተግባራት ቅድመ ተከተላቸውን በጣሱ ጊዜ ለሲስተማቲክ ኤረር ያጋልጠናል። Flaws in the experimental setup or procedure can introduce a systematic bias. Third one is environmental factors. Factors like temperature, humidity, or electromagnetic interference can affect measurement in a consistent way. Another one is a human error, consistent mistake made by the experimenter, such as misreading instruments or misinterpreting data, yields, causes, or considered as the causative agent for the systematic errors. If so, to ensure accurate measurements, what we have to do, it is essential to identify and minimize systematic errors by the following conditions. 1. This can involve calibrating instruments. 2. Carefully designing experiments. 3. Controlling environmental factors. 4. Using appropriate data analysis techniques. The second one is known as random errors. Are errors that occur unpredictably and then can vary in magnitude and in direction. Look, this means that they are not constant like systematic errors, and then their effects on a measurement are not always the same. Right? So, key characteristics of random errors include 1. Unpredictability. They occur randomly and cannot be easily predicted or controlled. Variability. That means their magnitude and then direction can change from measurement to measurement, which is not constant as what we have seen systematic error. Another one is impact on accuracy. While the random error can introduce some uncertainty into a measurement, their effects are generally less severe than systematic errors. What are the common causes of random errors? Or simply, common causes of random errors include fluctuation in environmental conditions. Factors like temperature, humidity, electrical noise can introduce random variation in instruments. 2. Instrument limitations. The inherent limitation of measuring instruments can cause small, random variation in readings. Another one will be the human error. Mistakes made by the experimenter, such as misreading instruments or making calculation errors, can introduce random errors. If so, to minimize or to avoid the impact of random errors, we have to do something. Among them, repeat measurements multiple times. Averaging the results can help reduce the effects of random errors. Great. The another one is using high quality instruments. Instruments with better precision and accuracy can help reduce random errors. Another one is controlling environmental conditions. That means maintaining stable conditions can minimize the impact of environmental fluctuations. Great. Already we have discussed a lot. We have discussed a lot. Uncertainty means, this sign in uncertainty means plus or minus. It indicates the range within which a measurement is expected to lie. For instance, look, if a measurement is reported as 10.5 plus or minus 0.2, this means the true value is likely to be between 10.3 and then 10.7. So the plus or minus 0.2 represents the uncertainty or error associated with the measurement. Great. Another subtopic is known as significant digits or significant figures. Significant digits are the meaningful digits in a number that contribute to its precision. Great. So significant digits represent the accuracy of measurement or calculation. They represent the accuracy of a measurement or calculation. Yes, as we said, significant digits are meaningful digits. But what the meaningful digits? They are the digits that convey the accuracy of a number. Great. Precision. Yeah, significant figure or simply significant digits indicate how precise a measurement or calculation is. And then the more significant digits, the more accurate the value. The last one is significant digits help maintain the context of a measurement and then prevent misinterpretation. Right. On the next turn, for significant digits are significant. Example 123.45 and all are significant digits. And then we may say 5 significant digits there. 2. The row or leading the rows. The rows before the first non-zero digit are not significant. Simply they serve only to indicate the size, the magnitude of the number. Example 0.0123 simply serve only to indicate the size, and hence we have 3 significant figures 1, 2, 3, but these leading the rows never be considered as a significant figure. Third one is running the rows. The rows after the last non-zero digit are significant only if the number contains a decimal point. Look example 1230.0 and then look this 0 and then look this 0. Generally, this figure consists of decimal point here and then, or in such a case, the rows considered as a significant figure. They not act for magnitude or size, but they considered as a significant figure. And hence we have 1, 2, 3, 4, 5 significant digits. Great! This is all about our discussion or our lesson. Till we see on the next lesson. Goodbye. Bye bye. Thank you, my dear.